If you're still using AI in the browser, you are doing it the slow way. If you've ever used Cloud Code or Cursor CLI as an agentic AI tool on your terminal, you'll understand what I've built in this project. It's surprisingly easy to build a custom effective agent as long as you have a LLM at your disposal. So before jumping into further details, let me demo you on what this agent actually does. I've already configured all the necessary things required for the agent to function. So first, let's give it a prompt on to create maybe a calculator app. I've already created a folder for that. Calculator, as you can see, there's nothing in it. So let's run the code, main.py. What we'll ask is give me a fully functional terminal calculator app. Let's give this prompt. And as you can see, I'm giving this prompt in natural language, obviously, similar to what you would do to an AI. And you can see there has been a calculator.py app built already, and it's still running. Okay, so it says the execution timed out again. It seems the passing arguments directly to run Python file doesn't simulate the interactive input that the script accepts. Unfortunately, I am unable to interact with the running Python script to provide input as a user. Therefore, I cannot fully execute the calculator as intended. How the calculator file contains the correct code. Okay, it says that the code is there. Let's go into that. Okay, perfect. As you can see, it has written a function to do the calculation. It has written and it says, okay, let's try this out. Let's run the code. UV run. It's in calculator. Calculator and calculator.py. Enter the expression. Let's do 2 plus 2. And it works. So we have a fully functional calculator app, and let's do 67 minus 3. Great, the calculator app now works, and this was fully written by the agent. Now let me exit out of it. And now what we'll do is let's introduce a bug, right? And hypothetically, this is just a calculator app, but you can use this for building any project. And let's say we don't want to return the result. This is a bug. And let's also say, let's put a syntax error for the if break statement. Now let's save it. Now we know if we try to run it, it's not going to work because the syntax is incorrect, and we also introduce a bug right here, which it doesn't return the value. So let me now ask the agent to fix this. So UV run, let's run our code and say run calculator app, and if it's not working, fix the code for me. Again in natural language, let's give it to the agent, and it's calling the predefined functions as I mentioned. As you can see right here, voila, it just fixed the code, and it's again running the Python file, just making sure everything works as expected. Okay, for some reason today, it's the day I try to record a video, it's comparatively slow, but usually it's pretty fast. And let me also run you through the architecture on how I've built this. And the whole idea of this project was to see how hard or easy it is to build an agentic AI tool, which gets a lot of work done. And right here you can see the expression is 2 plus 2. It also like validated its own input, and as you can see, the calculator now app works. Let's try running it. Calculator.py. I love AI. It just overwrites. So if your prompt is not accurate, tries to fix it and up for it. But yeah, overall this is what the project is about. For example, if you haven't had this, typically what would people do? They would copy paste it in the browser, and then once the LLM fixes it, they take it and then paste it again and then go over that loop, which is a lot of pain. But this is sort of a toy version of Cloud Code, or sometimes even GitHub Copilot, all of these agentic AI tools. So now let me run you through high level architecture on how this thing is built. Where is the flowchart? Yep. So this is the flowchart, and on a very high level, the tool accepts a coding tasks, and it is specifically built for coding tasks and in natural language. That's the cool part, right? You can give it a coding task in natural language, similarly to what we did, build a calculator function or a script, and then it chooses from few predefined functions which I've written, and I've already mentioned those functions. The get file content, this is the predefined function. The get files info, this is the predefined function. So what we've told the agent was, hey, you have these 4 predefined functions, and also we have declared, this is very crucial, we have declared which directory it should be restricted to. This is a really crucial part because we only wanted to access files within that directory. We can't let it loose and access all your sensitive information. You don't want to feed sensitive information to any LLM. So make sure that you have this working directory configured if you're about to use this project for your own purposes. But these are the 4 tools which has access to. So it's going to build a function mapping to say, okay, these are the 4 tools I have access to. Which tools make sense for me to start working on this task which the user has given. For example, let me run this again. So if I say run calculator app, it knows that to run the calculator app, first it needs to get the files info. Get files info function, all of this is written in Python, as you can tell. The get file info is right here, and what this function which I've written does is it gives the information about all the files within that directory. And once it knows, okay, it has calculator.py, then it's gonna run that Python file. And run Python file is a function which will run Python files. So as you can see, if it ends with .py, it's a Python file and you can run it. Now, where were we? The flowchart. Yep, right here. And once the function mapping is done, it sort of iterates through, and I've also set a max iters configuration, and it's a while loop until that loop condition right here where you see it is less than max iterations. The reason this is done was because we know that AI hallucinates a lot, and if the prompt is not correct or if the model cannot handle the task which you've given, it just keeps on iterating, and we don't want to do that because it costs a lot of tokens. And the version I'm using right now is a free version of Gemini. Let me actually show you the model itself. It's right here, Gemini 2.0 Flash 001. And all you need is to configure your client ID in the .environment files, and also configure the max iters and the maximum characters. These are just limitations so that the AI doesn't go on wild. And once that is done, it sort of iterates through the entire iterations, and it either gives you the correct answer or it fails miserably, which is possible, and you can see sometimes it does whatever it wants. If you want to see the source code of the entire project, I have kept the link down in the description, or if I'm posting this in LinkedIn, then as a header. And feel free to contribute to this project, and also if you want to use it for your own purposes, use it at your own risk, because this is just, again, as I mentioned, a very baseline version of building one of these coding agents. But I feel like this helps out a lot if you are a developer and you have to iteratively modify code or change code. So I hope you guys liked this video, and if you did, please let me know about the feedback. I can make videos like these or run you through the entire code based on how I build this, or we can either do a walkthrough as well. Thanks guys, peace.